James Webb Space Telescope has hardly opened its eyes, and the universe is new.
Did you know we're on the brink of building telescopes that could directly capture images of Earth-like planets in other solar systems? Not just as tiny dots, but detailed enough to study their atmospheres. When it comes to the future of space telescopes, there are some real trailblazers out there. Ones that will make the current James Webb Space Telescope, or JWST, look like it was made in the Stone Ages. The JWST is currently the rock star of the telescope world. Imagine it as the sequel to the Hubble telescope, but with way cooler gadgets and a much bigger stage to perform on. Launched on Christmas Day in 2021, it was like a holiday gift to the world of science. And let me tell you, it didn't disappoint. This telescope is a game changer. It's got a mirror that's about 21 feet wide. This giant mirror helps it capture light from the farthest corners of the universe. We're talking about looking back over 13 billion years to see the first galaxies that ever formed. But it's not just about size, it's about smarts too. JWST is packed with cutting-edge tech that allows it to see things in a way no telescope has before. It can look through dust clouds to see stars being born, and it can even give us clues about planets far, far away, planets that might even be a bit like Earth. So when we talk about the legacy of the James Webb Space Telescope, we're talking about a tool that has redefined what we can see and understand about our universe. It's not just a telescope, it's a time-traveling, planet-hunting, stargazing wonder. And the best part? It's just getting started. So hold on to your seats, the next chapter in space exploration is going to be a wild ride. Let's start with John Mather, a Nobel Prize-winning physicist and one of the key minds behind the James Webb Space Telescope. He's not just resting on his laurels, he's already thinking about what's next. Mather is keen on the idea of even larger telescopes that can delve deeper into the mysteries of our universe. He's a big advocate for groundbreaking technologies that can make these giant scopes a reality. But it's not just about one man's vision. There's a whole team at NASA's Ames Research Center working on something called the Fluidic Telescope, or FLUTE for short. This isn't your everyday telescope, it's designed to be created in space itself. The mirror would be shaped using a unique fluidic method in a microgravity environment. This technique has already been tested successfully in labs, and even aboard the International Space Station. The idea is to make telescopes so big and so advanced that they can directly image Earth-like planets in other solar systems. So the future of space telescopes is looking pretty bright, and it's all thanks to these visionaries who are pushing the boundaries of what's possible. The Vera Rubin Observatory, previously known as the Large Synoptic Survey Telescope, or LSST, is indeed located in Chile. Specifically, it's situated on the Cerro Pachon Ridge in north-central Chile. The observatory aims to conduct a 10-year survey of the sky, capturing a wide array of astronomical phenomena. However, the statement that it will spot millions of points of interest each night might be an overstatement. While the observatory is designed to scan the entire visible sky every few nights, it's more accurate to say that it will catalogue billions of objects over its 10-year mission, rather than millions each night. The observatory's main goal is to provide a comprehensive view of the universe, capturing transient events like supernovae and asteroids. It will also contribute to our understanding of dark matter and dark energy. The 8.4-meter primary mirror and 3.2 gigapixel camera make it one of the most powerful survey telescopes ever built. So while the Vera Rubin Observatory will indeed be a groundbreaking facility for astronomical research, the claim about spotting millions of points of interest each night may need to be dialed back for accuracy. If you thought the Hubble and James Webb Space Telescopes were impressive, wait until you hear about the Habitable Worlds Observatory. This project is like the next level superhero in the telescope universe. It's been given a thumbs up by the Astro 2020 Decadal Survey, which is a big deal in the world of astronomy. Now, what makes this telescope so special? First off, it's designed to be huge, around 6 meters in diameter. That's a lot of telescope. And it's not just about size, it's about what it can do. This telescope will have high contrast imaging and spectroscopy capabilities, making it a powerhouse for spotting signs of life on planets far, far away. But here's the kicker. Let's talk about assembling this bad boy in space itself. Yeah, you heard that right. Thanks to advancements in rocket technology, we might actually build this telescope in orbit. Imagine the possibilities when you're not limited by the size and weight restrictions of a rocket launch from Earth. So the Habitable Worlds Observatory isn't just a successor to its famous predecessors, it's setting the stage for a whole new era of space exploration. The 30-meter telescope, or TMT, is a project currently in progress that aims to have a telescope with a diameter of 98 feet, or 30 meters. This telescope is part of a collaboration between multiple countries including Japan, the US, Canada, China, and India. The primary mirror of the TMT will consist of 492 hexagonal panels. The telescope will be suited at an altitude of 13,163 feet and will focus on analyzing black holes in the Milky Way and other galaxies. Ground-based telescopes like the TMT can work in tandem with space observatories for a more comprehensive view of the universe. While space telescopes like the Hubble and James Webb have the advantage of being closer to celestial objects, they are restricted by weight and size. Ground-based telescopes can be much larger and are not limited by these factors. They can focus on specific areas or events, providing a different but complementary set of data to space observatories. This collaboration allows for a more complete understanding of cosmic phenomena. The future of astronomy and space exploration is set to be revolutionized by advanced technologies and hybrid systems. One of the most intriguing concepts is the hybrid space-ground setup, which aims to combine the capabilities of both space-based and ground-based telescopes. This approach can offer the best of both worlds: the clarity and reach of space telescopes, along with the stability and ease of maintenance of ground-based systems. Now, speaking of space telescopes, let's talk about their secret weapon, coronagraphs. Coronagraphs, which are instruments designed to block out the light from a star so that nearby objects like exoplanets can be observed, are becoming increasingly sophisticated. The James Webb Space Telescope JWST, for instance, is equipped with powerful coronagraphs that allow for detailed imaging studies of exoplanets. But the technology doesn't stop there. Scientists are exploring the potential of placing a giant star shade in orbit. This star shade would work in tandem with a telescope to block out starlight, making it easier to detect and analyze distant objects in space. So what's on the horizon for these telescopes? According to a 2023 article on phys.org, the next generation of space telescopes could be as large as 100 meters in diameter. These telescopes would be constructed in space and could be bent into precise shapes using electrostatic actuators. This technology is part of the NASA Innovative Advanced Concepts (NIAC) program for Phase 1 development. The idea is to overcome the limitations of current space telescopes such as size and surface precision by using advanced materials and in-space manufacturing methods like bend forming. Bend forming is a novel in-space manufacturing method that uses a single strand of wire bent at specific nodes to create a stiff structure. This technique is low power and well suited for the extremely low temperature environment of space. Electrostatic actuation, on the other hand, allows for the precise shaping of metallic mesh into a curved shape, which acts as the antenna reflector. These technologies could lead to telescopes with a diameter of more than 100 meters and a surface precision of 100 micrometers per meter. The future of space telescopes is not just bright, it's dazzling. With advancements like hybrid space-ground systems, coronagraphs, and potentially even giant star shades in orbit, we're on the brink of a new era in space exploration and understanding. These technologies will not only revolutionize how we look at the universe, but also deepen our understanding of it. As technology continues to advance, so too will our ability to peer further into the cosmos, answering age-old questions and undoubtedly raising new ones. If you're as fascinated by this as we are, you don't want to miss our in-depth video on the James Webb Space Telescope. It's a deep dive into one of the most groundbreaking telescopes ever built, and it sets the stage for all these exciting developments we've just talked about. So go ahead, check it out, and get ready to be amazed.